Hello, everybody. This is a review on the multiple choice questions that we had last week. So I'm going to go through a few of them. I think there's 6 in total. I'm going to go through, actually, there's 7, 2, 9, 17, 18, 19, 21, and 25. So number 2, as you can see in your packet, the question is f of x equals the function. We'll have a vertical asymptote at question mark. So we have all those answers. So hopefully most of you got to this point where, you're trying to factor it and see where it's going to have vertical asymptotes. X can't be -1 here, as you can see, as this is factored. This is now in factored form. I factored the 3 out of here, and then I factored the numerator in blue, and then the denominator is factored there. But x can't be -1 because that's going to make the denominator 0, which can't happen. But it's not going to be a vertical asymptote. It's going to be a hole here. It's going to be a hole at -1, and at +2, that's going to make the denominator 0 as well, and that's going to be a vertical asymptote. So I'm not sure which answer most of you guys put, but the answer is going to be answer A. That's where you're going to get a vertical asymptote. Okay, this is number 9, and in number 9, you're trying to take the derivative of g of x. So you need to rewrite g of x. That's probably the first best thing to do. So it's going to be 5 times sine of 6x quantity squared plus 5 times cosine of 6x quantity squared. So now you can use the power rule in the first of your chain. So now I'm taking the derivative. So g prime of x is going to be 10 sine of 6x, 1 less the power. Now we take the derivative of the inside. So that's going to be times cosine of 6x. And then I still have to take the derivative of the inside, so that is going to be 6. So I'm going to add, so basically you get the same thing on this side, where now I'm taking the derivative of using the power rule, and it's actually going to come out to be pretty much the same except for the sine and cosine. Cosine of 6x doesn't get touched. 1 less the power means 1. Take the derivative of the inside, but now it's a minus sine x minus sine of 6x times 6. So if you simplify this, where I say all the time in class you don't have to simplify, but now you do because you have multiple choice problems that have to fit. So that 10 and 6 are going to end up being 60, and that's going to be sine x, sine of 6x, cosine of 6x. And then the other term is going to be, you have a 10, a 6, but you also have a minus sign. So it's going to be minus 60, excuse me, sine of 6x, cosine of 6x. So this whole thing cancels out and is 0. Okay, this is number 17, where you have the integral from, the definite integral from 0 to 6 of 2 minus the absolute value of 4 minus x dx. So the thing with this is you don't always necessarily have to use a fundamental theorem of calculus, and I wouldn't here. This is more of a kind of a graphing exercise where I have an absolute value function. We talked about these a little bit in class when I have really 2 different linear functions is what an absolute value function turns out to be, where I have 2 minus 4 minus x, and then I have 2 plus, I'm sorry, 2, I have 2 minus 4 plus x. So those two turn out to be, if you look at them, this one comes out to be 2 minus 4, which gives me a -2, and as I distribute that x, you get a positive x, which is just a linear function, x minus 2. And then this one comes out to be 2 plus 4, so this one comes out to be 6 minus x. So I have my two linear functions that come out to be my my function. Now, what I need to figure out is really where does it separate? And in absolute value functions, it separates where the inner part is going to be 0. And you probably talked about this in Algebra 2. So when is that 0? That's when x equals 4. So they separate at 4. So you can, sketch a graph of this pretty easy. And hopefully you'll be able to see that after the sketch of the graph, it is really easy to find the area. There's no really fundamental theorem that you have to do here. So when I sketch it, I have my y-axis and my x-axis, and I know that it changes at 4. So at 4, I'm going to get a change. Well, what's the value of the top function at 4? Well, the top function at 4, the value is going to be 2. And what happens to that function? That function has a slope of positive 1. So it's going to be 0 when the function is 2, and it's eventually going to go down and hit -2. So I'm just sketching this, just sort of matter-of-factly. So I'm going to try and figure out what the area is here, and the area is here under the curve, between the curve and the x-axis. I know I'm not doing a great job of calculating that, or sketching that, but I know it's going from 0 to 6, so I've got 0 to 4 covered. So I only have to cover 0 to 6 now. When I plug in 4 into this function, I'm also going to get 2, so I know I have that point there, and it's going to go, I have a slope of -1, so it's going to go down 1 over 1, down 1 over 1, and when it goes to 6, and as you can see with even the function, if you plug in 6, you're also going to get 0. So I think you could pretty much see that this area under the line, I'm getting hopefully better at this, but anyway, under the line is going to be the same area as this between the line and the x-axis. So those two are going to cancel, and this is a triangle of length 2 and of base 2 and height 2. So it's going to be 4, 2 times 2 divided by 2 is just going to be an area of 2. Okay, this is number 18, and this is just the integral, or the indefinite integral of sine of 2x, blah, 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 blah. So you see that there. So really, this is a matter of simplifying all this stuff. This just looks like a mess. If something looks like a mess, you got to look to simplify it. So tan x, and this is really your trig function training here. Tan x, hopefully you know, is sine over cosine, but it's squared, so it's sine squared over cosine squared. 1 over cosecant, or cosecant is going to be 1 over sine. So now it's, because it's squared, it's going to be 1 over sine squared x. And that's really the key to this whole problem. I mean, the rest is just kind of cleaning it up and doing it, because you can clearly see that those sines, sine x squared is going to cancel. So now I'm left with 5 over cosine squared x. So hopefully you can see what's happening with that. So I haven't even done any calculus yet. I've just done all trig. So the first part, you could do a couple of different ways. You can use your u/du substitution. So if you use u/du substitution, I'll just explain it very, very quickly. Is you're going to have that extra half and extra 2 really that you don't have here. So you have to divide by 2. So the antiderivative of sine is minus cosine, and it's going to give you an extra half in there. And then the antiderivative of cosine squared x is tangent, and that 5 is just a constant, so that just comes along, so it's 5 tangent plus c.